being here today. My name is Jim, and I've been teaching developers to write secure code for almost 20 years. And I've noticed like the last couple of years, the pull for AppSec training has begun to fade a bit. We're starting, like when it comes to technical security bugs, we understand how to fix them, and we have for some time now. And I noted a couple of years ago that the AI era was beginning. So about 3 years ago, I decided I'm gonna build out all AI security courseware. I believe that's the future. And I did this at a time when a lot of my business partners around me said, AI is junk, you're wasting your time. So this year and the year before, even though I'm an AppSec educator, I found that people who traditionally would purchase secure coding education are now buying AI security classes. So we can teach developers how to build secure AI systems. AI systems today, there's all these new security problems that we haven't had to deal with in the world of normal software development, right? So it's a whole, for those of you who've been studying AppSec, who've been studying information security, AI, from my point of view, it's very exciting. It's mammoth capability that's changing the world around us. And it's a new opportunity for us to extend our skills when it comes to security and learn things like managing training data, using AI for natural language input validation. There's a whole new set of controls and defenses and processes we need to build secure AI. That's been my life the last couple of years, immersed in AI education. But what I realized is I use also AI a lot in my own software development. And the productivity gain as a senior developer, I've been writing code professionally since the 90s, and the productivity gain is off the chart. Anyone know what percentage of code Microsoft develops with AI? It's like 30% now. It's off the chart. Can you imagine 30% of your code being done via automation tomorrow? That will change most businesses. So everyone's rushing to use AI to write code, very often without thinking through it, because we're new at this. So I see a lot of companies, they buy a Copilot license and say, hey developers, go use Copilot, rock. Or they'll say, hey developers, like go use Claude and set them loose with these tools. And I think that's a big mistake. I don't think anyone should be using AI raw. So what I propose, and I'm gonna frame this topic around React. I'm gonna frame this topic around React just so I'm not talking about the abstract. I wanna show you what we're gonna do today is I'm gonna talk about the flow of AI-based software engineering, number one. I'm gonna look at it in React and see where React makes mistakes when it comes to React software development, where developers make mistakes doing secure React user interfaces. Third, we're gonna look at how to do React secure coding properly and see what the controls are to be a very secure React developer. Then we're gonna open up 5 of the frontier models. We're gonna look at we're gonna do this live, wish me luck. Copilot, Claude, we're gonna look at ChatGPT 5, we're gonna look at Grok, and we're gonna look at one other. Like we'll look at the 5 main engines and ask it to write us React code, and we're gonna analyze it and see where AI goes wrong. The top models of the day with very clear requests are making big mistakes. And then we're gonna teach AI how to do it properly through the art of prompt engineering. I'm gonna build a prompt with you in this presentation that explains to AI, act as a secure React developer, here's what you need to get right, here's where you're usually making mistakes, and this is how you get it right. And we're gonna teach AI to write code and then go back and issue the same requests and see what the difference is. Before I get too far ahead of myself, people have asked me many times, why does AI write insecure code? And that's an important question to understand this technology. First of all, who wants 30% productivity gain via automation in their software engineering today? Who would like, yeah, everyone on the planet wants that. But this tool is very refined. You can't just use AI. It's a tool that requires proper use, right? And so within a frontier model, what do we have today? Let me get off my, I'll stick here for a second. Within a frontier model, it's pretty much absorbed the open source code of the world, especially the top 5 models. But when you look at React, most people using React in open source, they'll use a function like dangerously set inner HTML on a raw string. We see it all the time in open source. And so AI, when you say, render HTML from a user, it's going to use that common code, that insecure code that most developers do. So we're going to say to AI is, hey, we're going to give it a rule that we can repeat, that we can deploy as an agent, that we can deploy as fine-tuned model, that we can deploy as a MCP agent, that developers can just dump into their IDE. And we're going to tell things to AI like, hey, look, AI, if you're going to use the dangerously set inner HTML function, then please use DOM purify on that variable before you render it. And AI has got plenty of examples of that, so it does it. So AI has examples of secure and insecure technical code. You have to explain to it which one is secure. And that's the process of modern development. And one more thing before I roll here. What I see the industry doing now, I don't see anyone deploying prompts that help AI write secure coding up front. I think that's the way to roll. Very few people are doing that right now. What most of the security companies are doing is they're leveraging their code scanning technology like static analysis and similar, and they're using agentic looping, where you write the code, it will pass the code to another agent that reviews it for vulnerabilities, it discovers vulnerabilities, sends that back to the main coding engine that fixes some of those bugs, it sends the code back to another engine that reviews it, it loops for a couple hours and leads towards secure code. This is where the industry is going, and it's completely wrong. Let me explain why. I believe it's wrong because right now, the main frontier models, they supplement our token usage because they're basically startups. And so when you go to agentic looping, what does that do? It takes time and it burns tokens, and that's expensive. Everyone in the AI world wants AI to be expensive, right? Because it will prop up this industry that's cracking a little bit right now. And I do not want to make it expensive. I want to make it cheap. I'm a cheap bastard and proud of it. So by doing prompt engineering, they're text files. What are they going to do? They're going to teach AI to write secure code and eliminate technical vulnerabilities up front. And that's something that I'm doing. I think something anyone with the right knowledge could do. Let's talk about it. So the AI lifecycle is, number one, you need the expertise. You need a human expert who understands React at a very deep level from a security perspective. And like any large company, we want to build security requirements with our human experts. I even think those requirements are so important. If we're going to move to AI, I keep my requirements under source code control. And then and my rules as a human, those of you who know me, my rules are very verbose. My first generation of rules had all the edge cases, and they were several paragraphs long. AI doesn't like that. So I maintain my human rules for human communication in one area, and then I ask AI, each individual engine, to convert that rule to a concise rule that uses minimal tokens that will still fire well. It often takes a sentence that's like 4 compound rules mapped together and breaks it down into 4 separate, very brief rules, so it fires better for AI. So literally, AI is helping me take security requirements and turn them into prompts, 1 rule at a time. Then I'm going to apply the rules to a session before I write code. I'm either going to just dump it into, if I'm using a web interface to write code, I just dump the rules in before I start a process. If I'm in the open AI world, then I'll deploy a private agent, a private GPT for React secure coding or for .NET secure coding, and deploy that to my team. I can deploy an MCP agent. I can embed the rules in the IDE's markdown file for artificial intelligence integration. I can use it in a DevOps pipeline to do review. When you get the rules right that AI understands, you can use these secure coding rules at multiple layers within the AI secure coding flow. And then I ask AI, write that code for me. And then and sometimes, if I'm really trying to do something precise, I'll apply my rules before AI writes code, and then apply rules after AI writes code. What I've learned is that AI will sometimes fire on rules better up front, and AI will sometimes do better with an existing code to work against, depending on the rule. And then I'm still gonna be a mature AppSec person. I'm gonna run SAST and secrets management. These days, I really recommend you do not run a SAST engine. Run 2 of them, right? There's a lot of really good engines out there. I typically run with I'm a typically more like a semgrep or a shift left or a lightweight engine, and a heavyweight engine like a Checkmarx or like the Fortify type stuff. They're very differently developed engines, but I still run SAST against all my code. And there you go. This is what I think of as the modern AI workflow, where you're prompting AI to get it right up front. Some of the other things I noticed about AI when it comes to coding is AI typically is not writing very maintainable code. In the world of software engineering, we have principles, like the dry principle, like WCAG requirements for accessibility. We may want to have administrative code isolation. We got rules for design, and everyone has a different opinion. What about what about variable naming conventions for your code? Anyone have an opinion about code naming conventions? Do you like camel case? Right, a lot of you are camel case developers. I like a form of from a variable naming convention called Hungarian notation. This is an older notation for variable names. And if anyone love Hungarian notation like I do, in my 27 years as a professional developer, the number of people who loved Hungarian notation with me would be 0. But that's okay. That's why these prompts can be different for every architect's vision, right? And so when it comes to maintainability, here's an example of what my rules look like. Number 1, maintain low cyclomatic complexity. Write simple modular code for readability, testing, and bug prevention. This will have a low number of linear paths through that function. The next one is minimize cognitive complexity. Make the code easy for a human to understand. We're minimizing the logic here. Does anybody know the coder? Does anybody know the archetype of a coder who loves to do clever things in their code? Do you know that archetype? You fire this person quickly or get them to change their ways. Because if you're doing a personal project, then clever coding is great. But if you're doing the team sport of enterprise development, clever coding just is destruction to your company. It's hard to maintain. It's hard to analyze. So that's my opinion, by the way. Some teams are full of clever coders, and that's their philosophy. Good luck with that. For me, though, I want my engine to write minimal, complex code. Even if it's more verbose, it's going to be easier to read. It's going to be easier for AI to understand. It's going to be easier to audit and maintain over time. So those are my first 2 rules. The third one is around damp and dry. Avoid code duplication. Reuse code effectively to promote the damp and the dry principle. This is about code reuse in an intelligent way. I'm being opinionated here. Every architect, when they're prompting AI to write code for them, should start and specify 6, 7, 8 different architectural opinions. I like high cohesion and loose coupling. I like certain kinds of, I want a clear naming convention across the whole stack. I use a single responsibility principle and assure accessibility. These are 7 simple, non-compound rules that take up very few tokens that AI understands. Many developers will comment on their code. Hey, I'm using dry in this section. So it's going to lead AI to write these principles more, and when they're writing code, what that means for you is future AI or future humans looking at that code will have an easier time maintaining it. And think of this is about money. It is. It's about make cost-effective software. When you write code that's more maintainable, the average cost to maintain that software goes down dramatically if you stop doing hard to maintain clever things without proper encapsulation of that complexity. So anyways, but let's get into React for a second. I'm going to skip talking about cross-site scripting. I want to go over a couple basic React rules. React is interesting. It has dominated the field of user interface development. It is by far, it's beat out Flutter, it's beat out Angular, it's beat out Backbone, it's beat out Svelte and Vue, and not by a little bit, by a wide margin. It's somewhere in between of usability and functionality, and I think I'm a big fan of it. But React wasn't built well for security. It just wasn't. There's gaps in React that we just don't see in frameworks like Angular. So in order to use React securely, we have got, as a developer, we have to do validation, data sanitization, and escaping on our own manually in many situations. So the first thing I'm going to tell AI, I'm going to change the role of AI. When you fire up ChatGPT or Copilot or similar, your role is you're a generic developer. I don't like that. So the role I set first is for my framework. Please act as an expert, idiomatic React.js 19.2 developer. 19.2 came out last week. So I make sure I'm specifying what version I want AI to write. What does idiomatic mean? There's a fancy word. When I say idiomatic React developer, what do I mean by that? It's part of the cleverness, right? What I'm saying is write idiomatic standard React code. Build React the React way. Don't do anything out of the box or clever or non-standard. The more we go off the rails and do non-standard React coding, the chance of security bugs happening goes up significantly. So I'm saying, hey, look, just do normal React development. We're 19.2. We're going to focus on security, maintainability, and again, idiomatic behavior. Let's not write anything strange. We have a lot of examples of standard React code. When I look at React, I'm worried about two things. I'm worried about the attacker doing view source, because very often React developers, they're embedding secrets, they're trying to do access control, they're embedding sensitive data within their client that shouldn't be there. So the first thing I worry about as an attack is just the attacker looking at the source code for secrets in the code. And the second problem is content injection, which we've known for years as cross-site scripting, right? So when I look at React source code, I never want to do something like this, right? If the user role is admin, display an API key, again, I view source and I got the API key. This is providing zero security. And many React developers that are like modifying like an old Java server page to React, they'll make this mistake when they're updating legacy software frequently. So when I look at code in React, I want to see no hard-coded secrets, no access control, no unsafe React methods, direct DOM manipulation, the eval function props or types should not have raw input. They will lead to cross-site scripting. I want to keep sensitive data out of local or session storage. I want to keep away from out-of-date third-party libraries or misusing libraries. Or one of the biggest bypasses of React is a user-driven URL being rendered raw. That can lead to a JavaScript or a data URL leading to XSS. So in the client, I got to validate URLs, not just escape, to handle the URL problem, which we'll look at in just a minute. So let's zero in on a couple problems in React that we can emulate through AI coding lifecycle. The first one that I want to look at here is going to be the URL problem, right? How would you bypass this code in React? Say the user homepage is user input, and there's my JSX code in React. I got an anchor tag, href, user homepage. Those of you who are security attackers, how do you bypass this? What URL can I submit that will cause JavaScript to execute when someone clicks on that homepage? Anyone? Here's the main bypass. It's a JavaScript URL. We know HTTP, HTTPS. JavaScript URLs will execute JavaScript live, and yet it's a legal URL. Now, I want to highlight this because Angular will note that you're doing this and block JavaScript URLs. It validates. React, Vue, Svelte, all the big ones, they do not do any security at this layer. So if you're, and this is such a big deal when it comes to cross-site scripting across the world. I look at the research at Google from Spagnuolo, Weisselbaum, and Chris Christoph. These are like JavaScript and content security policy leads and standard body leads. They tell me that 1/3 of all successful cross-site scripting that becomes a real incident, they're JavaScript URLs, because the browser does not stop JavaScript URLs from executing. Content security policy can't easily stop a JavaScript URL. Myself and a few architects, we submitted to W3C a standard that said, let me disable JavaScript URLs on a page as a response header, and we were repeatedly denied. They're like, we don't think that's necessary right now. But yet Google tells me 1/3 of all successful XSS is because of JavaScript URL. This is the #1 problem in React. Now, you can solve it by having your API only give you a valid URL. You can solve this by having the API validate the URL. But how much should my React client depend on an API giving me the right data? How much should your JavaScript client depend on the API giving you secure data before you display it for security? And my answer is none. We want our user interfaces to be 100% self-defending. This is an academic technique called perfect injection resistance. We're going to assume that every variable from the API is dangerous, and we're going to protect it in some way. That's the art of secure React development, right? And so one of the problems is if I have a payload that's a JavaScript URL, in this case it's landing in a form action, that will be escaped in JSX, but then it will be recoded and execute. When you escape a URL in an attribute, it is still going to fire. That's the problem. Even though the URL is escaped in the payload variable, that's not the problem. The problem is the URL is not validated properly. And it's not just me saying this as a crazy security guy, right? Here's ESLint, the main linting engine for JavaScript, right? And so I see that the URL is going into the href attribute yet again, and ESLint is going to tell me, hey, script URL is a form of eval. This is dangerous. And ESLint, it's not even a security engine. It's a linting engine that's telling me I shouldn't be doing this. And I agree. This is a huge problem. And AI, when I ask AI to do certain things, it makes this mistake all the time. In fact, let's switch gears and go take a look at that, right? I'm going to go grab my React demo. Here's the section. Here's what I'm going to try to do right there. Bang. So see, even if I'm going to temporary, it's still going to fire off my account rules. It's not going to save it. So it's doing all the things that I prompt. I'm going to try a different engine. See, the problem is ChatGPT is doing it correctly because even though it's a temporary chat, it won't save it. It still leverages these settings on my account, which all have the default secure rules in. Let's look at something else though. Let's go try Claude, right? I need a raw ChatGPT account to show it off, but I'll show you something later in just a bit. So let's try Claude. Let's try the web-based version of Copilot. Let's try Grok, right? So let's try one more. What else? We got, oh yeah, Gemini. Let's try Gemini. Let's do all this live. So let's see what we got. Let's take a look at this. So I just asked Claude one version off the main one, right from in React, user profile page with the username, first name, and so on. Let's see how they did. So first of all, Claude is rendering a user homepage raw and an href right there. That's a giant gap. No client should ever do this. And again, Angular, since Angular 1 would auto-block that. It's not blocked in React. That's a major vulnerability and weakness. Then we have dangerously set inner HTML on raw user input. If you're using dangerously set inner HTML on raw user input, what kind of life are you living? You're living dangerously, exactly. This is not a complicated mistake that Claude is making. It is an egregious, obvious mistake for a React developer. And I give Claude an F when it comes to technical security fixing. This is not acceptable, and it's especially not acceptable at scale. Next, we have Copilot web version. Then we got Grok, Super Grok. Then we got Google Gemini. I'm gonna use the Flash version for now. Still will show the point. Is Claude already proved it's not gonna rock. And let's see how Copilot will do, right? Copilot it's using DOM Purify, that's good. So Copilot is sanitizing the description, and it's sanitizing description in DOM Purify. That's a good thing. And again, this is a probabilistic engine. When I run Copilot, I see over the last year and a half, it will do it secure about 10% of the time and insecure about 90% of the time. These are predictive models. It sometimes gets it right, but it frequently does not. So even though it's doing DOM Purify on dangerously correct, it's still rendering that homepage raw, which is the bigger problem. That's a third of all XSS. So Copilot in this example, they're getting like a D+, right? It's a D+ or so. Then I take a look at Grok. Grok is doing a straight up F here, right? Grok has got the href on the homepage. It's got dangerously set inner HTML on the description. It's really clean code, but it's complete. It's a straight up F minus, Elon, because I want secure code here. It's not even close, but it's clean code at least. Then I got Gemini. Gemini's got the PhD power of Google, right? And all that goes with that. And they're great. They're like, hey, Jim, this is terrible security. You can't render raw HTML in dangerously set inner HTML. This is a security warning. You shouldn't do this. And we're going to then just do it anyways. So like, in my experience, comments about security don't help write secure code, right? So even though Gemini knows better, it decided to do the insecure code anyways. And I do not understand what the heck is going on here to do this. Then down here we see the homepage. Actually, I do. You can ask AI, how come you gave me a comment to do DOM Purify, but why didn't you actually do it? AI will explain its reasoning. That's helped me build my prompt. So actually, you can ask AI why you're doing this. They'll usually give you a good explanation of what got to that decision. And they're putting the homepage in the href again. This is the state of AI coding today. It's relatively clean code. It's incredibly fast. I can do some cool, complex things. It helps me out. But these low-level technical bugs that's been the heart of our work in our communities here for like 20 years, it's doing terrible. Do you see the same thing in your work? Anyone else have visibility into this? Are you seeing the same thing? AI making mistakes on very basic, like technical bugs? Does it make it hard? Does it make adoption difficult in your company? So when I'm building a project, I prompt, here's my architectural guidelines, concisely. Here's my maintainability guidelines. Here are the only libraries I think we should use in this project, and here are the secure coding rules. And the difference is night and day, radically so. So let's take a look at one more thing here before let me go back to the presentation here. I want to show you, again, one more major thing, a few more major things, right? When I'm rendering a user-driven URL that a user authored, I can't just drop it in an anchor tag. I need target is blank, and REL is no opener, no referrer. This is to stop cross-tab attacks called tab napping, right? So I got to make sure putting user URLs in the right anchor tag, and I need to make sure that I'm running user-driven URLs through client-side validation. That's Angular's choice as well. Why client-side validation? Again, my philosophy is I don't want to trust that the API gives me a certain kind of data. I want React to be self-defending on the client. So I'm going to tell AI to use this function. You got to be a URL, you got to be a legal URL, and the only protocol I'm going to accept is HTTPS, or I'm going to render a pound. This is the function that Angular uses that's missing in React, and we're going to teach AI to use it for us in React. The second rule I need is render user-driven and any other links to URLs with a target is blank, REL, no opener, no referrer, and href, run the validate and sanitize function I just defined. So these are some of the rules I'm giving to AI to make it behave well. Let's look at what the script really looks like, right? I'm setting a role, act as an expert idiomatic React 19.2 developer, and then the coding rules. Use JSX to escaping. If you're gonna use avoid dangerously set under HTML, but if you're gonna use it, sanitize it with DOM Purify and integrate it into trusted types so it fires automatically. If you're gonna put data into dynamic CSS, then use CSS escape. And if you're gonna handle a user URL, then use this exact function. Now, why did I write the function instead of asking AI to do a validate function? What I find is if I explain how the function should work to do security, it varies. It's a regex one day, it's URL class the next day. When it comes to security, I can't tolerate that kind of predictive variance. I need to do it right. So in this case, I'm gonna say, hey AI, this is what your validate function must look like, just do this. When you see too much variance, then you give it a code example. You're getting my access control wrong. Well, here's 10,000 lines of code where I'm doing access control right. Please emulate this behavior. So I need code samples for certain things sometimes. For the URL validator, I went through about 30 versions of this. This is the version that fires well. That's the function, and then when you're gonna run it, here's the exact markup to use. There's a reference back to the function, and it solves the problem. Then I wanna use the right new React router routing. I wanna use the navigate to stop open redirects in an allow list. I wanna do comprehensive input validation. I wanna use Zod. I wanna make sure I have good prop hygiene and similar third-party library discipline, minimize dependencies. So I have my formula. Whoa. So let me go back for it. There we go, I'm sorry. So here's my little prompt here, right? I got a role, expert React developer, default escaping, avoid dangerously, use DOM purify if you're gonna use dangerously. Let's use trusted types to auto bind our sanitizer into the React page. Here's your function for URL validation. Here's how you render a URL. Here's how you do secure routing and avoid open redirects. Here's all my validation rules, some weird edge cases. Here's my component creation hygiene around types and props. Here's my third-party discipline. Number one, minimize dependencies. The open source third-party React plugin community is a morass of insecure filth no one should use. So please stop using 400 plugins with React so your table has a curved edge, right? That's what's happening. And that leads to exploits and incidents because you used a library so your table corners are round. And now I got XSS through that. That led to an incident and you lost money because of your round tables. So I really try to teach developers, stop using 200 libraries on top of React or Angular, keep it minimal. And I can tell it to a developer and they have their opinions, but I tell it to AI and typically will get close to listening as the rules become more refined. Don't combine template with strings, don't store secrets, I try to avoid rules on anti-patterns, but I do say, look, inner HTML, outer HTML, they're all dangerous. Here's the code quality rules. Keep cyclomatic, cognitive, and complexity low and similar. And final goals, XSS resistant React code. Protect this code from XSS no matter what data you get from the API. And if you know a secure React coding rule that's not listed above, then please apply it by default. Of the engines we looked at, who did the worst job here? What would you say? I think Claude is pretty close to the worst. Go Claude. Let's go back to Claude now. I'm doing this. This is a live demo. Yeah. So we're looking at. I'm gonna go Sonnet because I'm not paying for Claude. So I'm gonna go one below Sonnet, and I'm gonna dump my prompt in first and apply it. Again, this is one of many ways I can deploy these rules. I can do a Gemini gem. I can use a individual GPT agent. If you're in the OpenAI world, go search on Secure React Architect. You'll see my React GPT live in the OpenAI marketplace, right, for free. You get an open prompt, you start with the prompt rules like I did just here, and this is good for agentic workflows, MCP, it's good for private agents, you can dump it in the browsers, a markdown file for AI instructions, you can put it in the profile of your AI account for rules, I tend to use it as a private GPT agent that I then attach to an IDE. You can use it through Cursor. The Cursor's got a whole bunch of security rules that are very basic. They're like, hey, you should do secure code. Do some validation. That's what their rules are. So again, here we go. We've now applied the rules. I reviewed the secure React 19.2 development guides. I'm now operating in expert mode with focus on XSS prevention, client-side safety, proper sanitization, secure URL navigation, WCAG accessibility, modern React idiomatic patterns. It got it. It's ready to rock. So let's go back to that same instruction, right? The same exact thing that Claude did so terribly on a few minutes ago. Create for me in React user profile page with the username, first name, last name, homepage URL as a link, profile description as HTML from the user. Let's see how Sonnet can handle this request now that we prompted it to be a secure coding React developer. See if we're any better here. Right away, I see it's a lot better. Right away, it's awesome, but we're gonna analyze it. Give me one sec, let this finish up. There's all the, by the way, all these ARIAs in here, this is all the WCAG rules firing for accessibility. The difference, in a future talk, I'll diff it so you can see it a bit more clearly, but here we go. We're now loading DOM Purify, which it wasn't doing before. There's the validate function. It's making sure it's a string. It added other protocols, right? I said HTTPS only. It added HTTP, mail to, and it added tell. And none of those add risk. HTTP is not a good protocol, but in terms of executing JavaScript, no big deal. So these are legal protocols. The main URLs that cause XSS are JavaScript URLs and data URLs, right? So we're at least stopping those. That solves the validate problem. And what about the HTML problem? We have, there it is. It's got a sanitizer. It's specifying some rules. It's got a regex for a URL. I'm not a super fan of that, but it's okay. And then DOM Purify Sanitize on the user, DOM Purify Sanitize on the user description. It's now the clean variable. So what we want to see down here is we want to see when it's rendering the home page, it's rendering the sanitized URL with blank, no opener, and no referrer. That's ideal. Perfect. Good job, Claude. Something I don't say often. All right, and then we got dangerously set inner HTML on the sanitized description that went through DOM Purify. That's clean. This is awesome. Where to get the sanitized description though? Let's go. Let's look at it, make sure. I'm gonna be 100% clear here. So it's the sanitized description variable. Now who is rocking with that? There's the sanitized URL. There you go. Oh, there it is, right there. Sanitized description. And where do you get to there's the clean variable. But why are you rendering you should be, I want to render the clean variable. So what is it doing? It's rendering sanitized. I think I want to swap that out with clean. Yeah, so it probably wouldn't even compile, but it's in the right direction though. So Claude, you get an A- on this. Do you see the difference though? And so what's the process here then? What's the process? The process is, let's go back to this one more time. The process is, again, capture expert human rules, right? Convert those into AI rules. Apply the rules to your session, write code, save money, and get much better secure coding results up front. I think this is so, I'm not gonna talk about, I think this is so important. I actually sell these as like a product, right? And I'm gonna stop there. I'm not here to sell. I show you the techniques of how I build these prompts. I hope it's valuable to you in your work. What I'm gonna release is, I'm splitting hairs here, right? What I'm doing is, if you look inside of my presentation, look at all the slides that are like this. The slides that have the red bar on it are the breakdown of most of my rules. The actual prompts I write is something that's for my customers. I sell those. But the presentation in detail explains you how I got to each major rule. So I'm getting you like 90% of the way there without hurting myself. Is that fair? Sure. It's hard. I'm like, how do I be an open source? I'm trying to juggle a lot of things at once, but the presentation will walk through it. Also, one more thing. I'll show you one more thing. If you go to the OpenAI world, where is it? If you go to the ChatGPT world and go take a look at, I got you. If you go to the OpenAI world and you go to, where is it? Explore, and I want to look at my GPTs. This is probably where I would go, right? If you go to, let it load on my phone. We're rocking. A lot of the work I'm doing in prompts, I roll them out as like GPTs, right? On the OpenAI marketplace. So if you take a look at the React one, see if I can get to your, sorry about that. If you go look at the secure React architect, all my rules are live in the GPT marketplace. There's like hundreds of people using it right now. I'm just struggling with the internet or who knows what's down right now. It's not perfect. It's not going to solve all your problems, but here we go. Go look at the Secure React Architect. It's for 19.2 that came out last week. I just updated. And this is how typically I like to roll out prompts. Again, go to Explore. I was just there, I'm sorry. Go to My GPTs one more time. Go to the Secure React Architect. And you can see how I've built this little agent here, right? Secure React Architect, there's description, there's my prompt. And if we keep going down, you'll see it's for code interpretation or web search only. And I pushed it live to the whole world. And so you can see it in action and use it in production right there. There's hundreds of people using this right now. I can do static analysis and code scanning and code review, but typically a developer needs to be educated on security to write secure React code. That's what I do for a living, right? And it works. It's not perfect, but it works. You got, again, most major companies in the world, they teach their developers on secure coding on a yearly basis. And that's something smaller companies tend to skip out on. That knowledge is critical. And I found that if I build one generic secure coding prompt, it only works so well. But if I do it framework specific for React, for .NET, for Angular, those framework specific rules fire better than generic secure coding agent rules. And that's exactly one way you can deploy this. Thank you all for your time. Have a wonderful conference.